again about the mini tests, which you can take all next week. That is a 1 week only opportunity to make a big difference in your grade. Obviously, when more test points come, then those test points average together. So, you know, with more tests, your grade will go up if you do better on those tests.
Will they be like more smaller this time when we take like our next test for like the year?
Well, you can see what the next test is pretty much.
5 minutes away and you managed to be
minutes away, buddy.
So if you look on the calendar, you can see what's covered on the test. I think this is a kind of everything test, but it's all together.
Rounding is 5. No, for rounding.
buddy, ain't nobody here for you.
Okay. We are talking about parallelograms today. We were talking about quadrilaterals, or not quadrilaterals, polygons. So we spent the last couple of days doing a lot of stuff on polygons. And now we're getting into very specific quadrilaterals. Quadrilateral is any four-sided figure, but there are some that have some very special features. So parallelograms are what we're talking about today. And a parallelogram, we want to be able to identify the properties of parallelograms and use them to solve problems. So a parallelogram. What is the root of the word parallelogram? Parallel. That is the root of the word. Parallel. So what do you suppose a parallelogram has? Parallel lines. All right. It is a quadrilateral. A quadrilateral, so a four-sided figure in which both pairs of opposite sides are parallel. Very important. So we do have two pair of parallel sides. Very important. Let's see. So I'm going to draw a picture because I think it's important to, you know, have a good baseline here. So here we have some sort of parallelogram shape here. There we go. It's a goodish parallelogram. There we go. All right, four-sided figure. So go ahead and draw yourself that parallelogram. We have here parallel sides. We recognize those markings as parallel. Okay. What does it mean if they're parallel? They'll never touch.
They never intersect.
They never intersect. They have the same.
They go on forever. Length.
They are the same length. They actually are. That is true. They have the same slope. Okay, we're going to use that. Okay, so we have two pair of parallel sides. As Clayton said, they have the same length as well. Opposite sides are congruent. So the opposite sides happen to also be congruent, which is pretty cool. So if I have a side length 5 here, what's the opposite side?
5.
Also 5. And if I have a side length 7, what's the bottom side?
7.
Also 7. Mark that down. It's a good visual to remind you that those opposite sides are the same length. Okay? Let's see. If the sides are congruent, then I'm going to have some angles that are also congruent. Opposite angles are congruent. Opposite angles are congruent. That's interesting. I'm going to come back to that. Let's see, what else? We have parallel lines. So we have a parallel line here and a parallel line here. So I have two parallel lines, and we're being cut by a transversal. So these angles right here and right here, I'm putting two dots there. So I have a single dot and then the double dot there. Those two angles have a special name. Anybody remember? No. We have parallel lines cut. They are supplementary. They're same side interior angles. Yes, they are consecutive interior angles, which means they are supplementary. So, because of parallel lines, consecutive angles are supplementary. Because we have parallel lines, so what does that mean? Let's say this angle is 100 degrees. What's this double dotted angle I put here? 80. 80 degrees. They're between parallel lines, so those interior angles, those consecutive interior angles are supplementary. And we can continue working our way around because we have another pair of parallel lines here. So if this one is 80, what's this angle over here? 100. Okay. And if this top angle is 100, what's this bottom angle down here? 80. Okay. And so we can pretty easily see, just by knowing we have parallel lines, that not only are consecutive angles supplementary, but the opposite angles are congruent. Okay? So really easily working our way around that way. Let's see. Also, last but not least, the diagonals bisect each other. The diagonals bisect each other, and that's kind of interesting. So if I draw some diagonals, I'm going to use my red pen here to draw some diagonals. So diagonals go from opposite corners, all right? So here are the diagonals. It turns out they end up bisecting one another. So one diagonal gets cut into two equal parts, okay? And the other diagonal also gets bisected into two equal pieces. Are they the same length? No, absolutely not. And in fact, you can draw a triangle, or sorry, a parallelogram where it's very obvious. Let me see. Here we go. I'm going to draw a very obvious, the diagonals are not the same length. So here I can draw a very squat parallelogram. Here's a very short diagonal, and then here's a very long diagonal. Clearly their diagonals are different lengths, okay? But they still end up bisecting each other. So they get cut into little equal parts, okay? All right, so really important to have a very good picture that shows you all the nice things about a parallelogram. We have lots of information to build on when we're talking about a parallelogram. So let's look at a couple problems here. All right. Each quadrilateral below is a parallelogram. It's important. We got to know all these properties of a parallelogram. We want to find the missing measures. So let's go ahead and look here at number 2. At number 2, I'm just going to fill in my parallelogram and then go about answering the questions, okay? So let's see. First, if I know that MJ is 29, what else do I know?
KL is 29.
Got another 29 over here. And 21 on the bottom, then we also have 21 on the top. Very good. All right. If I have 127 degrees at angle L, what else do I know?
53 degrees. Supplementary.
Okay, so next door, we would be supplementary at 53 degrees. And what about angle J? Also 127 because opposite angles are congruent. And then angle K must be 53 for the same reason. So we figured out everything. So JK is 21, KL is 29, angle J is 127 degrees, angle K is 53, and angle M is 53 degrees. All right, really easy there. Very good. Let's look at number 4. No, I see. Let's do number 3. Okay, we've got some 18, some 27, and then there's this little extra information down here. It says RT is 30. What is RT? The Diagonal, okay. So RT is the diagonal. The whole thing is 30. What happens to the diagonals?
It gets cut in half.
So what, oh, so both sides are 15. So I'm going to go ahead and draw that on so I can put that in my picture here. All right, so let's see. So with that information, I also know what's ST? 18, and RS is 27, so UT is 27 on. All right, 18 on the right, 27 on the bottom. All right, so UT is 27, ST is 18, VS. Oh, 7. I didn't even see the 7. Good job, guys. Yes, there's a little baby 7 right there. All right. Hey, VS is also 7. Good, good, good. I didn't even see that 7 on the picture. I was like, this is my blind spot. Okay. And so VT is 15. All right, great. Okay, let's look at number 4. Lots of things to think about here. We have some angles that have been marked. We have a 21-degree angle, this little 71-degree angle, and it says the measure of angle FED. FED. That is the whole angle is 134. All right. DEC. Oh. No, let's see. The whole thing is 134, and we know part of it is 71. We want to know DEC. What is this other side? How'd you get 63? Yeah, 134 minus 71 equals 63 degrees. So that is 63 degrees. 63 degrees right there. They do not bisect the angles. So the angles don't get bisected in this. So that's important to recognize. Those angles are not going to be both 21. That happens in another figure, so we have to keep them all straight, okay? All right, let's see. CDE. All right, so the whole angle E is 134. CDE, what is this whole angle up here? No. Those angles do not get bisected. All right, the whole angle E is 134. This whole angle down here is 134. How'd you get that? 180 minus 134, yes, is 46 degrees. Again, the consecutive angles are supplementary. You've got parallel lines. So we get 46 for that whole angle there. All right, so over here, the whole angle D is 46 degrees. What's the whole angle F? Also 46, very good. All right, we know, let's see, we want to find ECD. ECD. Ah, very good. How'd you figure that was 71? Yeah, we have that Z shape. We're going from parallel line to diagonal or transversal and then a parallel line. So we have alternate interior angles right there. So yes, those are 71 and 63. Okay, so we get alternate interior angles. Very good. All right, let's see. DFE. DFE. So we want to find this little angle right here. How are we going to figure that one out? Yeah, 46 minus the 21 is, what, 25? So that is 25 degrees. 25 degrees. Okay, so much going on with these parallelograms, all right? So really important that we see where everything is coming from, but we do get those alternate interior angles. So that's a good one to pay attention to. All right. Lots of information here. Let's look at number see. Oh, let's do 5 because it's got angles and side lengths here. So let's look at number 5. Let's see. XY is 15. Again, label your pictures, ladies and gentlemen. I think it's just the best way to do things. XY is 15. WX is 22. ZX is a diagonal. The diagonal is 32. What happens to diagonals? So 16 and 16. I'm going to write it right on the diagonal. WT is 10. WT is 10. What's the other side? TY is also 10 then. Good. Let's see. Angle. I'm going to do my angles in red here. Angle WZY. WZY. Oh, that's the whole angle Z there. The whole angle Z is 62 degrees. I'm going to mark that like that, which is a little bit weird, but that's what I'm going to do. So the whole angle Z is 62. WXT. WXT. Oh, the little baby. This little baby angle, WXT, is 27. So I can mark that 27. And ZWT. ZWT. That little baby angle is 77. ZWT. So that little guy there, 77. Okay, got lots of things to do here. Let's see. ZW is what?
15.
Also 15. Very good. ZY is 22. Also, opposite sides are congruent. TX is 16 and WY is 20. Beautiful. Again, when you mark the picture, answering those questions super easy, right? Okay, let's look at our angles. TZY. TZY. TZY is right here. It's just that bottom portion. 27. Why?
Because on the opposite other side.
Yeah, we got our alternate interior angles here. There's that Z shape. So that is also 27. 27. Alternate interior angles. Maybe make a note of that. Alternate interior angles. All right, XYZ. XYZ. That's my whole angle. What?
77.
How'd you get 77?
So I looked on the other side of like W.
So be careful. So XYZ. XYZ is the entire angle. The whole thing, not just the little Z piece of it. Yeah, we want the entire thing. 144? How'd you get 144? No, remember the angles do not get bisected. 118, how'd you get 118? Yes, 180 minus 62. The whole angle Z was 62, so Y is going to be supplementary to that. 180 minus 62 is 118. So 118 degrees. They are consecutive angles. They are supplementary. All right, XWT. XWT. Now that is just a little baby angle here. XWT is this little guy right here. What is the whole angle W? Also 118 degrees. Opposite angles are congruent. And we know 77, so what do we have to do? Subtract. Yeah, 118 minus 77. Yeah. So that is 41 degrees. 41 degrees there. And then XYT. XYT, again, is this angle. XYT right here. 77, yep, because of alternate interior angles. There's that Z shape, parallel line, transversal, parallel line, so 77. Alternate interior angles again. Lots and lots of things, ladies and gentlemen, to pay attention to. So lots going on in these. Do you have questions so far? What's my time on there? Sweet. All right, let's turn the page. All right, so once again, we've been given parallelograms, and if I have parallelograms, these are talking about the side lengths. What do we know about the side lengths? They're congruent. So what equation can we write?
9x minus 25 equals 5x plus 7.
Yes. And then do we know how to solve for x? Okay, so we can just set it up and stop there. All right. So opposite sides are congruent. Very good. Let's look at number 9. Maybe I write that down. Opposite sides are congruent. So when we have a little note of our reasoning, our justification. All right, let's see. TV. TV is a diagonal. A diagonal, the whole thing is 74. So what, 37? 37 and 37? Okay, let's see. And then WV. Oh, that's just a piece of it. Okay. So not only, let's see, so WV also has another name, 4x plus 1. Solve for x. So what can we do? What equation can we write? Yeah, 37 equals 4x plus 1. It has two names. All right, and we can solve for x, right? We don't need to do that? All right. Let's see. Let's go to number 11. Look at the information they gave us. What can we do with that information? Opposite angles are congruent. So opposite angles are congruent. So what equation can we write? 6x minus 15 equals 4x plus 11. You guys are both on the same page. That's good. So I'm going to go ahead and let's solve for x on this one real fast. I'm going to subtract 4x. That gives me 2 x's. I'm going to add 15. That gives me 26. So x equals 13. How do I figure out the measure of angle B? Yes, very good. So we're going to take 13 and plug it back in. So 6 times 13 minus 15 gives me 100. What does it give me?
Never mind.
I don't really know. I don't have a calculator, you guys. I'm going to need you. 117? Is that what I heard? Oh, for B. Oh, no. So for what's A, though? 63. Oh, okay. 63 degrees. And then if I want angle B, the measure of angle B is going to be 180 degrees minus the 63 degrees, and we get 117. Okay. Because they are supplementary. Okay, questions on those? All right, number 12. Look at the information they gave us. What do we know? Equals 180. Yes, they are supplementary. Consecutive angles are supplementary. So we can add them up and they should equal 180. So 3x plus 5 plus 8x minus 12 should equal 180 degrees. And I think we can go from there. Great. Are you guys doing okay? You're all good? Okay, let's look at 13. Let's see. The measure of angle KLH. KLH. That is the whole entire angle. The whole entire angle is 134 degrees. We want to solve for x. All right, the whole thing is 134. What are you guys thinking? Okay, 180 minus 130. Okay, so we know that the whole angle L is 134. Can we figure out the whole angle H? Which would be 180 minus 134. So what do we get? 46 degrees. Okay. And then, let's see, Maggie, you said that 25, so we know we have alternate interior angles here, so this would also be 25. But also, 4x plus 9 is up here. It'd be also down here, 4x plus 9. We have alternate interior angles are congruent. So Maggie said we could do that 25 plus 4x plus 9, equals that 46 degrees. So the 25 plus the 4x plus 9, those are all alternate interior angles. That's really good. That works. Yeah, that's the 4x plus 9. All right, so let's see. 4x plus 34 equals 46. And then we need to subtract 34. And x equals 3. Cool. And there's multiple ways to do this. Miss Wilson did it a very different way. All right, how do you feel? Pretty good? All right, super duper. Then you guys have a Delta Math